Hello. So what we're going to do now is we're going to do an application problem where we are using inverse functions. So we have a sharpshooter. I'm going to show you a figure. So you have a sharpshooter and they have a range from a target of 1,000 yards. Okay, that's given in the problem. And then you have a muzzle velocity, or we're just going to call it initial velocity because it's coming out of the gun at that speed of 1,050 feet per second. Okay, and we also have that the angle of elevation, we're going to be able to find this theta with this model. R equals 1 over 32 V naught squared times sine 2 theta. We're going to round theta to the nearest tenth place. So the first thing that I noticed is we have two different units of length. So the best thing to do, instead of trying to figure out this rate right here in yards, I will go ahead and make this, because this will be simpler. So there's 3 feet in 1 yard. So I would just multiply this particular number by, because we got yards, so I would multiply this by a factor of 1, where yards is on the bottom, canceling this yard out, and feet, which is the unit that we want, is on the top. Since these are equivalent, you multiply by something just to get the conversion of the unit. This still means 1. So we're not changing the meaning of the number, we're just changing the unit. So 1,000 times 3 is 3,000 feet, because those units are canceled out. All right, so now that we have our range in feet, got initial velocity, we need theta. So we're going to plug everything in to this model, use our feet version of it. So we're going to put 3,000 here for the range. We're going to put in the V naught number here. So 1 over 32, V naught is 1,050. It is squared times sine 2 theta. So what I would do is divide the entire thing by this coefficient, even though it's not simplified, to avoid any decimals. You could also do, just try to get to that sine function quicker, you could also move them one by one. Just for explanation purposes, that's what I'm going to do. I'm going to move, what color I want to use, y'all? Use orange. Okay. So we're going to multiply both sides by 32. So we can move this 1 over 32 out the way. If you multiply 32 times 3,000, you end up getting 96,000. On the left, these two are inverse of each other, so they divide out. 1,050. 1,050, I think I calculated that earlier. I'm going to check it again. 1,102,500 sine 2 theta. I believe that's what I got the first time when I did 1,000. Yes, when I did 1,050 squared. Okay, now we're trying to move toward that sine 2 theta, so I would divide both sides by this coefficient. So then we have 1102,500, 1102,500. Can you see that? Make sure that's being seen. I believe you can. All right, so now you can reduce that if you like, just a little bit, like that. See, get rid of 2 sets of zeros. These two will completely divide out because a number of itself is equal to 1. So on the right side, you're going to have sine 2 theta, which is what we want. Over here, I'm just going to put the reduced version without having to do too much work. Just since we're doing it by hand here, 960 11,025. Apply sine inverse to both sides. So you gotta move this over a little bit. So you have sine inverse here. Then you have a sine inverse here. Sine inverse and sine, they're inverse functions of each other. So these go away, leaving you with 2 theta on the right. On the left, you end up getting this arc sine function. You can leave it that way. You don't have to do anything fancy with it. You can just say sine inverse 960 over 11,025. Then divide both sides by 2, and we have theta by itself. So what you're essentially going to be doing is just typing into your calculator what you see here on the left. You're going to type in sine inverse, open parentheses, 960 divide 11,025, okay, all over 2. Don't forget to close parentheses. Also, something to note, make sure your calculator is in degree mode. You may be thinking radians, but for the purpose of this example, it's not really explicitly stated, so I just want to make sure that you check to make sure your calculator is in degree mode. Once you put this in the calculator, round to the first decimal place or the 10th place, you should get 2.5 degrees. And that concludes this example.